All right, welcome. And now we're going to start talking about section 7D, which is assessing risk. And so continuing on with our discussion with probability. Okay, so let's look at this graph here. It says, is driving getting safer? So if we look at this graph, the x-axis, the independent axis is time in years from 1970 to 2011. On the left primary y-axis, the primary axis here is deaths, number of deaths per year. And then on the right side, which is the secondary axis, is the vehicle miles driven. So we can see that the bars represent deaths, okay? And the blue line represents the vehicle miles. So you can see that vehicle miles have steadily increased over time, and that we've seen also that deaths, even though in the beginning, it's gone up and down from the 70s to the late 80s, it's pretty much evened out, and then in recent years has decreased. So it does seem like driving is getting safer. People are driving more miles, and we're seeing less deaths per year. Okay, so now one way we could do this is we could look at the death rate, right? Or death per mile, right? So the number of deaths per mile. So if we look at 1970, we see that 52,100 deaths happened that year, and approximately 1.1 trillion miles were driven. Okay, and so that gives a what? It's a point. It's 4.7 times 10 to the negative 8 deaths per mile. Okay, so a very, very, very small rate as far as deaths per mile. Then in 2011, if we look at the number of deaths per the number of miles, we get 1.1 times 10 to the negative 8 deaths per mile. Okay, so now if we want to compare these two, we can divide those two numbers. And we see that there's been a decrease of about 75% in the number of deaths per mile, which is really, really good. And so a lot of experts, look at this as a result of improvements like safety belts, airbags, and also the better auto design, right? The crumpled in fence, basically absorbing most of the impact has helped save lives and keep people safe. Okay, here, let's look at vital statistics. Vital statistics are basically causes of death, right? So if we look at the U.S. population based on the edition of this textbook or this PowerPoint presentation, 315 million people, we can find and interpret the risks per person and per 100,000 people for accidents and suicide. Okay, so here are the leading causes of death. Okay, and we want to find and interpret the risks per person per 100,000 people for accidents and suicide. So if we look at the table of causes of death, we see that accidents accounted for 122,800 deaths, and then suicide was 38,300. Okay, so again, if we look at these, okay, and these are the number of deaths, okay, per 100,000 people. So if we look at these, we could take the number of deaths for accidents divided by the total number of people in the United States, and we get approximately 0.00039 deaths per person. Okay, that's the death rate for the United States based on accidents. Okay, So if we want to write this as a percentage, this would be approximately 0.039% of the population, right, dies because of accidents. So very, very small percentage. Or we would say if we want to do this per 100,000 people, we would write it this way: 39 deaths per 100,000 people. So out of 100,000 people, we get 39 people will die due to accidents. Then we could do the same thing for suicide. Okay, so we do the same thing. We take the number of deaths caused by suicide divided by the total number of people in the United States, and we get a rate of 0.00012, or a percentage of the population, which is 0.012%. Or we can write it as a per 100,000 people, and it comes out to 12 deaths per 100,000 people caused by suicide. All right, now let's look at life expectancy. So if we look at this graph here, men and women, we can get a lot of information from this graph. Notice that they have almost like parallel lines, right? They increase and decrease together. But yet men are below the line for women. So it says here that basically men tend to die before women, and that is true across the board. In fact, the average the life expectancy for women is usually 7 years longer than men, depending on what study you look at. But for both of them, they've steadily increased. Life expectancy has steadily increased throughout the years from 1900 to 2010. And we can see that where there was a dip, right? Here. Okay. And then another dip here. So it might be interesting to see what was going on. Why did they happen? Okay, now using the figure to the side here, this is life expectancy. So of a 20-year-old person and a 60-year-old person. Now what this graph shows is this is life expectancy, right? What is life expectancy? It's the number of years that you will live beyond your current age. So if your life expectancy this is from 0 to 100. So at whatever age that you're at, okay? So the x-axis is age, and then the y-axis is your life expectancy in years, okay? So if you're 20 years old, right, you're going to live to be a little over 60. Or not 60, but you have a little over 60 more years to live. Okay, so let's I want to look at something here. So if we look at life expectancy, right? So this is the life expectancy based on birth, right? At any age. So if we look at 2000, right? So we see that our life expectancy is around here for men and women. Okay. So now we look at a 20-year-old, it's going to be about 60, maybe 62 years that they have a life expectancy for. So that means that at 20, they're expected to live 62 more years. If you're a 60-year-old person, right here, then you're around what? About 30? Okay, so let's see what they give us. Okay, so the graph shows the life expectancy for age 20 is about 60 years, and at age 60 it's about 23 years. So a 20-year-old would expect to live about 80, and if you are 60, then you're expected to live to about 83. So actually longer. So which is kind of cool, because the way this graph works is if the longer you live, the longer you're expected to live beyond that. Okay? So if you make it to 60, the chances of you making it to 83 are higher than it would be for a 20-year-old. Now, using the figure 7.15, determine how much life expectancies rose during the 20th century. Suppose life expectancies rise by the same amount during this century. What will the life expectancies at birth be for children born in the year 2100? So now this is based on the graph that looking at men and women. Okay, so if we look at this graph here, and we look at men and women in 1900, men lived to be about, what, 46, and women lived to be about 48, maybe. And then in 2000, women were about, what, 79, and men were at, what, 74? Okay, so that's going to be, we're going to take those differences, and that's going to be give us the increase over the 100-year period. And then we're going to assume that that continues, and we'll calculate the life expectancy at the year 2100. Okay, let's do that. So it says here that life expectancy at birth rose from about 48 years in 1900 to about 80 years in 2000. So that's a difference of 32 years for women. And then for men, they went from 46 to about 74 in 2000. So that's an increase of 28 years. So if we assume that this happens for the next 100 years, then in 2100, we would expect the life expectancy to also increase by that amount. So life expectancy for women in 2100 would mean they would go from 80 to 112. And then life expectancy for men, if it rises another 28, would go from 74 to 102 years. Okay? Now, there's nothing to say that that will happen, but it's just an assumption. What if? All right, that's it. And if you have any questions, please reach out to me if I have office hours or email. And then also definitely use the tutoring center. They are there to help you. And I will help you as much as I can. Okay? Have a great day, and I'll talk to you later. Bye.